you. Right, so okay, we wait and see whether any more coming in or not. Okay, nobody coming yet. Okay, right. Let me revise what we have learned in the last lesson. Now, in the last lesson, somebody, when I think when you differentiate the square root, okay. So let us look at this square root here, right? Square root one uh, product, one function is x, another function is square root. Okay. Now, when you differentiate the x, then the square root remain. The square root remain means this is x to the power of positive half. Positive half, that means this term will remain at the top, at the numerator. Okay, so this is it. Then while you keep the first function, differentiate the second function, you bring down half is okay, but when half minus 1, when you minus 1, half minus 1 is actually negative half. Negative half, while the other function, right, is comes from the differentiation of the inside the bracket. So you have this one remains at the top. This function 2x minus 2 remains at the top, right, of the 2 cancel away, so you have this remain at the top, and this negative half you can put it at the bottom, at the denominator. Now when you want to add this term together with this term, one square root is at the top, another square root is at the bottom. Now how you go about adding this? So you remember this one? This one. The algebraic fraction a over b plus c over d is, you cross this, ad plus bc divided by bd. Okay, so these two terms, I want to add them up. This is a, this is b, this is c, and this is d. So you cross this denominator with the numerator of the other term. So when you multiply them, you see that they are both the same. They are both the same term, right? So you just add the indices together, half plus half. Half plus half become 1. When you multiply the denominator 1 with the numerator on the other side, multiply by 1 means the same thing. So over here, you can remove the bracket because the power of 1 is the same, right? So x plus x become x squared, 2x plus x become 3x, and negative 1. So the square root at the bottom, you can change back to square root. So using this one, right? So afterwards, when we do the differentiation of square root, we are going to use something like this again, right? Maybe slightly different if it appears at the uh, denominator, but if it appears at the numerator, then it will be the same. So you just need to remember this thing, this thing. Okay, next. Yes, this is the question that you asked me just now. Okay, so I have uh, colored the two different functions in two different colors. This is the product of two functions. The first function is 4x minus 3. I colored it pink. And the second function is 2x plus 7 raised to the power of 6. Color it orange. Okay, it's orange. So now I'm going to differentiate the pink color, and keep this orange color. The orange color remain the same. Then afterwards, I'm going to differentiate the orange color. Then I keep the pink color, pink color. So okay, start. We differentiate the first one, the pink color. 4x become 4, right? And this term I just copy down. No need to differentiate. Okay, second one, I differentiate the orange color. Orange color is 2x plus 7 to the power of 6 minus 1. Then I differentiate inside the bracket again, I get 2. Then the other function, 4x minus 3, I just copy down, no need to differentiate. So the first term, 4 multiplied by 2x plus 7 raised to the power 6, I just copy down here, no change. Now the second term, I need to gather the numbers together. When you gather the numbers, 6 times 2 becomes 12. And this term become power of 5. And this one I copy down. Now so far I have only differentiated the function. I have not done the factorization. I have not done the factorization. Now when you want to factorize, you must not take out the 4. Then this one you don't take out the 4, cannot. When you want to factorize the 4, when you take out the 4 and put in front, then the 12 should become 3. But if you take out the 4, right, and the back remain the same as 12, that means it's wrong. Because if you factorize the 4, the term behind, you must divide by 4. Then in that case you don't. Right, now if you cannot see, never mind. You just take out this term first. 2x plus 7 raised to the power of 5. So take out 2x plus 7 raised to the power 5. Now here you have not factorized the 4's. The 4 is still inside the bracket. Then here 2x plus 7 to the power 6. You take out 5, you are left with 2x plus 7 raised to the power of 1. Okay, so you have taken out this orange color, so you are left with 12 and this blue thing here. So 12 and the blue thing here. So don't try to factorize. If you cannot, don't try to factorize 2 factors at one time. But of course, when you have done it many times, it is very easy. You just can see how many factors you want to take out simultaneously, can, right? But if you cannot see, take out one factor at a time. One factor at a time. Okay, so now the 4 I didn't take out, the 12 also I didn't take out. They remain inside the square bracket here. Okay, now the next step will be take out the 4 lah. Factorize the 4. So I factorize the 4 I put in front. This one I copy down the same. Here no more 4. This bracket I can open up. 2x plus 7. Now the 12, you take out the factor 4, you are left with 3. 3 together with this bracket. You have not taken out this bracket, so you just leave it there. Okay, now the first 2 terms you just copy back the same. This one copy the same. Now here 3 times 4, 12. 3 times 3, 9. Now you can simplify. 2 plus 12, 14. The rest is the same. The rest is the same. 2 plus 7, 2 plus 12, 14. 7 minus 9, negative 2. Right? So this factorization is not complete. Normally, they will ask you to simplify. When they ask you to simplify the answer, you cannot leave it as 14x minus 2 because there is a common factor 2 in each of these terms, each of these 2 terms. So 14, you take out 2, becomes 7. 2, factorize the 2 out, become 1. So the 2 that you take out, multiply with the 4 in front, becomes 8. I have checked already. This answer is correct. Okay, any questions? Any questions?
Teacher,
Yes.
teacher,
Yes.
I give an example. Like if 12 bracket 4x minus 3 and then raised by power 2, that one we can times the 3 into the bracket
4x
minus 3.
to the power of
No, 3 bracket 4x minus 3 raised by the power 2.
3 bracket
4x minus 3
4x
minus 3.
4x minus 3 minus 3 eh, minus how many? 3
3
raised to the
raised
power
by
of
power 2. 2.
to the power of 2. Is it like this?
Yeah. If
Okay.
like this means we can times the 3 into the bracket.
Cannot, because the 3 has no
Power.
power of 2. Okay.
Okay, okay.
Now,
Okay.
if you see a bracket and it is raised to the power of something, don't play with the numbers in front. Don't multiply inside. Don't multiply
Okay.
inside.
Yeah.
Now, if you multiply inside, then becomes like that. Like that means this one multiply become 12x 12x minus 9 to the power of 2, which is wrong. You are actually increasing the power, because you see here the power of 2. Now earlier on the 3 has no power of 2. So if you put it inside, that means you are actually that, and outside there's a still power of 2 outside. That means you are giving the 3 power of 2, which is wrong. Which is wrong. Actually the 3 has no power of 2, unless we have 3 to the power of 2. Unless we have 3 power of 2, which is not always the case. Which is not always the case. Okay. Oh, so you don't do like that, you don't do like that, right? You don't do like that. Okay. Okay, unless you have something like this: 3 to the power of 2, 3 to the power of 2, right? Then bracket this one, 4x minus 3, also raised to the power of 2, also raised to the power of 2. Now both of them has power of 2. Both of them has power of 2. They have the same power. They are of the same order. Actually the correct word is the same order. So you can multiply the 3 inside, because as soon as the 3 enters the bracket, the 3 is actually has the power of 2 already, right? So you can write down like that. You can write down like this. You can write down like this. This is correct, right? Okay. Now you see the first case. In the first case, the 3 has no power of 2. And you put the 3 in, you are giving them the power of 2. But in the second case, you have 3 to the power of 2 here. And the second bracket also has power of 2. And you put them in, it is perfectly alright. Okay, it's perfectly alright, because you know the factor 3 has power of 2. When it enters the bracket, it has the power of 2 already. So the first one is wrong. The second one is correct. Any question?
No, teacher.
Huh? You understand or
Uh,
not? Must be very clear of
understand.
this. Huh?
Yeah, yes, understand.
Mhm. Okay, so where are we now? So I finished this, right? Now today we are going to do this part, exercise 2.5. The first one, two, three, I told you the first four questions they are about product rule. Question number 5 is quotient rule. So I'm going to show you what is quotient rule. And after that, you have one whole week to do all this, right? Try as many as possible. You cannot do, you put on the Telegram, then I will show you there. So if you accumulate some questions, then I will show you on the first lesson the next week. Okay, so now we look at the quotient rule. What is quotient rule, right? What is quotient rule? Okay, now quotient means division. So we have one function divided by another function. Okay, I mean I assume that you are looking at the screen and you can see the screen. If you cannot see the screen, my cursor, the black arrow, you please tell me, right? Okay, now this question, a question like this, with one bracket at the top, or maybe no bracket, never mind, with a function at the top and another function at the bottom, at the denominator. One at the numerator, one at the denominator, and this is quotient of two functions. That means it is the division of two functions, one function divided by another function. Okay, so if you see a line across like that, that means you use quotient rule. Okay, now how to use the quotient rule? Now in the formula, the quotient rule is like this. Quotient rule is like this: v du dx, u dv dx divided by v square. Okay, so now we are not going to do like that. Okay, now there are two functions, one at the top, one at the bottom. Top and bottom, we understand. I don't have to use the word denominator and numerator all the time. I just say top, that means I'm referring to the function at the top. Bottom, I'm referring to the function at the bottom. Okay, now for quotient rule, you have to differentiate the top first. Differentiate the top, then keep the bottom. You cannot reverse the order. You cannot reverse the order. You cannot differentiate the bottom first, then keep the top. You cannot, right? So the top, I have colored it pink. So I differentiate the pink, I get 2. And the bottom is orange color, and I just keep the orange color. Copy down exactly the same. Differentiate the pink color, keep the orange color, right? It has to be top first, then bottom. Okay, then another difference between the quotient rule and the product rule is the sign at the center here is no longer positive. The sign is negative. Okay. Minus, now you differentiate the bottom, then keep the top. Differentiate the bottom, become 3. So this 3 comes from the orange function at the bottom here. Differentiate. Then you have to keep the top 2x plus 3. So although you are still taking turns, but for quotient rule, you have to differentiate the top first. Product rule, which one you want to differentiate first, it doesn't matter, because it is addition. Addition you can interchange. It is commutative. Whereas in this case, the sign at the center is subtraction. So subtraction you cannot interchange, then you get wrong, right? Okay, so differentiate the top, keep the bottom. Differentiate the bottom, keep the top. Then the function at the bottom here, the whole thing raised to the power of 2. The whole thing raised to the power of 2. If this is power of 2, then you raise the power of 2 again, then becomes power of 4. Right, but later on we can, I'll show you. Okay, So now do you know what to do here? Differentiate the top, keep the bottom, subtract, differentiate the bottom, keep the top, then divided by the bottom, the function at the bottom square. So this is quotient rule. Can follow or not so far? Okay or not?
Sure. Can.
Okay. Okay. Then how to simplify? Simplify, you just multiply in 6x minus 2, negative 3 times 2, negative 6x, negative 3 times positive 3, negative 9. The 6x and 6x cancel off, it becomes negative 11. So the answer is negative 11 over 3x minus 1 square. Now this thing here, you can write it in many ways. The negative sign you can give to the numerator, or you can also give to the denominator. It's up to you. Now in this case, you can put it at the center here, then then you have to remove the negative sign. Okay, so one more time, one more time. Okay, so if you look at the function, you end up having negative 11 at the top, then the function at the bottom as usual. Now this negative 11, you can actually take and put it outside somewhere on the left of this term. So negative means the whole term is negative, rather than you give the negative to the top. Now both ways of writing is the same. The meaning is the same. The value is the same. But it is better to write it this way. Negative at the outside at the center there. Any question?
No, teacher.
No question. No question, then we look at the second example, how to differentiate. So from a linear function at the top and linear function at the bottom, we move on to something which is not linear, something like this. Not only the top is not linear, but we have coefficient there, the 2 and the 3. If you include the 2 and 3 as part of the function at the top and 3 as part of the function at the bottom, then these numbers, they will appear many times. They will appear many times. And even you have to square the 3 and become 9. You see, when you differentiate, you have to square the function at the bottom. So if you square this whole thing, 3x plus 5, then you become 9x plus 5 raised to the power of 2. So it's going to be very complicated. If this is the case, you separate the numbers and the function first. Numbers, you put it aside, you don't differentiate it, you only differentiate the x. That will be easier. Do you know what I'm talking about or not?
Yes, teacher.
Now, okay, so you see these numbers here, they are actually you actually multiply this number 2 and 3 with the function there. So I don't want to include it as part of the function at the top, this one as part of the function at the bottom, which is going to make my differentiation very complicated. So instead of leaving them like that, I take out the 2, which is at the top, the 3 at the bottom. So I actually take out a fraction. I actually take out the fraction. And what is left here is x to the power 3, x plus 5. X to the power 3, pink color at the top. X plus 5, orange color at the bottom. So what is the our word of mouth, how to differentiate. Differentiate the top, keep the bottom. Minus, differentiate the bottom, then you keep the top. And divide by the bottom, holding square. Okay, so I proceed. Differentiate the top. X to the power 3 become 3x squared. Then the bottom here, x plus 5, I just keep. Okay, then minus, differentiate the bottom, x plus 5. Differentiate x plus 5 become 1. 1. Then the x cubed, I just keep it. Then divide by the bottom here, this function, square. The square of the function at the bottom. So far, this step, the first step here, differentiation, can follow or not? If you cannot understand, just ask. Can follow. Other girls can follow or not? Okay, others can follow. Okay, so now differentiation is the most difficult part. After that, you just simplify. Now, to simplify, you expand or you factorize. Now, in this case, there are no common factors here, or except the x square lah. But never mind lah. I just expand first. 3x squared multiplied by x, 3x cubed. 3x squared multiplied with 5, 15x squared. 15x squared. Then negative 1 multiplied with x cubed, negative x cubed. 3x cubed minus x cubed. X cubed is 2x cubed. 15x squared. Now can factorize the x squared. Okay, take out the x squared here, become, you are left with x only. Take out the x squared, you are left with 15. Okay, then this number you can multiply back. 2 multiplied by x squared, 2x squared. The 3 you multiply with the bottom, become 3x plus 5 square. Oh, is this okay?
Yes,
Oh,
teacher.
okay, okay, then you try. You try. Where are we now? 2.4 chain rule. Where's the axis? Here, this one. 2.5. Okay. 2.5. You try. If A cannot, then you tell me lah. You try A and B. Try A and B. You have the textbook with you or not? Can I move to the example instead of these questions here?
Okay, teacher.
I go to the example. I go to example. You know this question. Okay. Maybe I copy this after I delete off. Edit. Copy. Copy. Edit. Then I paste it here. Okay. Here. Okay. Right. So now you try number 5A and 5B using what I've shown you, example 1 and example 2, right? You try now, then today why so long? No warning say that we have to stop. Normally 10 minutes more they will tell. Never mind. You try number 5A and 5B. You try now. Using this, you see the color, you can see clearly what I'm doing. Okay, are you ready? Are you ready? Ready, then I explain to you number 5a.
Okay, teacher.
Okay, right. Listen, listen. Ready, okay. Now, we have a function y equals to 3 over 2x minus 7. Now, I can treat this 3 here. I can treat this 3 here, the 3 here, as one function, pink color, and the 2x minus 7 here as another function, which is orange color, right? So this 3, which is at the top, right? When I differentiate 3, it becomes 0 according to my what? My quotient rule. I differentiate 3 becomes 0. Then 0, and I keep the function at the bottom, 2x minus 7. Okay, in the second part, when I differentiate the function at the bottom, 2x minus 7, I'm left with 2. Then the function at the top 3, I just keep it. Then divide by this whole thing square. Can you follow? Do you know what I'm doing now? Differentiate
Yes.
the top, keep the bottom. Then minus, differentiate the bottom, become 2. Then keep the top 3. Divide by the bottom whole thing square. So this is what you're going to get, right? So answer is negative. The 0 becomes 0 already, right? All the whole thing becomes 0. So 2 times 3 is 6, negative 6. Then divide by this whole thing square. Okay, so this is the answer. But from our knowledge of composite function, we can change this 3 over 2x minus 7 to 3 to the power of 2x minus 7, right, raised to the power of negative 1. So if we are going to do it like the composite function way, using the chain rule, we differentiate the bracket, negative 1, bring down negative 1. Then the thing copy, then this negative 1 becomes negative 2. Then you differentiate what is inside the bracket become 2. Now, is the answer the same? Is the answer the same? Negative 3 times negative 1 times 2 become negative 6. Then this thing raised to the power negative 2. Like that. But the negative 2 you want to write at the bottom, right? You want to put it at the bottom. Then it becomes negative 6. Then put at the bottom, the negative become positive already, right? So you see that the answer is the same. So you want to tell me which method are you going to use? Either one also can, right? But since we are learning the quotient rule, so you try to do it this way. Only this type of question where the top there is no x, then you can do it this way. You can do it this way, right? The composite function way. But if the top here, the 3, instead of 3 you have 3x, then you cannot. Then you can only do it using the quotient rule, right? So now this question, the second one, where is it? Yes, B, number 5B. You try number 5B. I'll post you a new link.